Imagine Earth, our home, not as a sphere but as a giant cosmic donut. Picture vast landscapes curving upwards, meeting a mesmerizing ring-shaped sky. Instead of sailing around the world, explorers would navigate this delicious-sounding landmass. We trade the north and south poles for an inner and outer equator, each facing the sun differently. Imagine looking up and seeing the other side of our planet, a breathtaking ring arcing across the sky. Get ready to see our planet with fresh eyes, to question everything you thought you knew about up and down. Let's face it, gravity is the real breadwinner of our cosmic bakery. On our spherical Earth, it pulls everything towards the center. But on a donut Earth, things get a bit more interesting, more complex. Imagine standing on the outer equator, feet planted firmly on the doughy surface. Gravity here would feel much like it does on our Earth, pulling you downwards. Now, picture yourself venturing towards the inner equator, the whole of our planetary donut. As you journey, you'd notice a strange sensation. Gravity, instead of pulling you down, would feel slightly weaker. You'd feel lighter, freer, almost like walking on the moon. This is because the mass of the donut is distributed differently, altering the gravitational pull. You'd be weightless, floating freely in the center of this celestial donut. On our spherical Earth, the equator is a belt of intense heat, while the poles are locked in icy embrace. But on a donut Earth, the climate would be as twisted as its shape. Imagine standing on the outer equator of our donut Earth. The sun's rays would strike you directly, just as they do on the equator of our spherical planet. This region would experience intense heat, lush rainforests teeming with life adapted to constant warmth. Now, journey to the inner equator, facing the sun's rays at a different angle. This region, despite being closer to the center, would experience a milder, more temperate climate. Life, as we know it, is a master of adaptation, evolving to thrive in Earth's diverse environments. But a donut-shaped Earth would present a whole new set of challenges, pushing the limits of evolution. Imagine creatures on the outer equator, adapted to intense heat and sunlight, their bodies sleek and efficient for traversing the dense rainforests. As we move towards the inner equator, life would take on a different flavor. Plants might develop reflective surfaces to maximize the limited sunlight, their roots reaching deep into the donut's crust for nutrients. Animals might evolve lighter bones, their bodies streamlined for navigating the weaker gravitational pull. Imagine birds with gossamer wings, soaring effortlessly in the thin atmosphere. A donut-shaped Earth would be a crucible for life, forcing it to adapt and innovate in ways we can only begin to imagine. On our spherical Earth, day and night are a familiar rhythm, a dance between light and shadow. But on a donut-shaped Earth, this celestial ballet would take on a whole new spin. Imagine standing on the outer equator, watching the sun rise over the curved horizon. As it climbs higher in the sky, casting long shadows across the landscape, you might notice something peculiar. The sun wouldn't pass directly overhead, as it does on our Earth. Instead, it would trace an arc across the sky, reaching its highest point at an angle. The length of day and night would vary depending on your location on the donut and the planet's tilt and rotation. Now, picture yourself on the inner equator, gazing up at the sky. Here the sun's behavior would be even stranger, moving in a continuous loop around the central hole of the donut. From our familiar spherical Earth, we gaze out at the cosmos with a certain perspective. But imagine the celestial wonders that would greet us from a donut-shaped Earth. The very way we view the universe would be forever altered. Picture yourself standing on the outer equator, looking up at the night sky. The familiar constellations would be stretched and distorted, their patterns warped by the curvature of the donut. Now imagine venturing to the inner equator. Here, the night sky would be a truly breathtaking sight. Without the obstruction of a full horizon, you could see stars in every direction, a 360-degree panorama of cosmic splendor. Constructing a civilization on a donut-shaped Earth would pose unique challenges. Buildings, bridges, and transportation systems would need to adapt to the curved surface and varying gravitational pull. Imagine skyscrapers on the outer equator, built to withstand the stronger gravity and intense weather patterns. These structures might incorporate flexible materials, swaying with the wind like giant trees to maintain stability. On the inner equator, where gravity is weaker, buildings could reach dizzying heights, their foundations anchored deep into the donut's crust. Lightweight materials and innovative designs would allow for structures that seem to defy gravity. Transportation would be another engineering marvel with high-speed trains and magnetic levitation systems. Launching into space from a donut-shaped Earth would present unique advantages and challenges for space exploration. The varying gravitational pull and atmospheric conditions would require innovative spacecraft designs and launch strategies. Imagine launching a rocket from the outer equator, battling against the stronger gravity to escape the planet's pull. However, once in space, the donut shape could offer a unique advantage: a gravitational slingshot effect. By carefully plotting their trajectory, spacecraft could use the donut's gravitational pull to accelerate and alter their course. Launching from the inner equator, where gravity is weaker, would require less energy to escape the planet's pull. Spaceports located here could become hubs for interplanetary travel. The search for extraterrestrial life is a cornerstone of modern astronomy. But our current understanding of habitable zones is based on the assumption of spherical planets. A donut-shaped Earth challenges these assumptions, forcing us to expand our definition of what constitutes a life-friendly world. The unique gravitational and climatic conditions of a donut Earth would create a wider range of potential habitats for life. Extremophiles might find refuge in the scorching heat of the outer equator or the perpetual twilight of the inner ring. Discovering a donut-shaped exoplanet would revolutionize our understanding of planetary formation and the potential for life beyond Earth. It would force us to reevaluate our assumptions about habitable zones. While we're on the topic of mind-bending shapes, let's take a moment to ponder the universe itself. Could our universe, on a grand scale, also be shaped like a donut? This concept, known as a torus universe, is a fascinating possibility explored by cosmologists. Imagine a universe that curves in on itself, connecting distant points in space and time. Just like on our donut Earth, a spaceship traveling in a straight line in a torus universe would eventually return to its starting point. While there's no definitive evidence to support a torus-shaped universe, it's a reminder that our understanding of the cosmos is constantly evolving. New observations and theoretical models challenge our assumptions and push the boundaries of our imagination. Our exploration of a donut-shaped Earth, while hypothetical, highlights the power of imagination in scientific inquiry. By asking what if, we push the boundaries of our understanding and open up new avenues for exploration. The universe is full of mysteries, from the smallest particles to the largest cosmic structures. By embracing our curiosity, by asking questions and seeking answers, we unravel the secrets of the cosmos and our place within it. So the next time you gaze up at the stars, remember the donut Earth. Keep asking questions, keep exploring, and keep looking up. For it is in the pursuit of knowledge, in the boundless realm of curiosity, that we truly discover the wonders of the cosmos and our place within it.